Today, I want us to do the mole concept, and I want us to start with two very simple things, empirical and molecular formula. So before we handle any question, I'd like us to understand what empirical formula entails and what molecular formula entails. Now, just from definition, empirical formula is the smallest whole number ratio in which atoms of element combine to form compound. So the keyword here is this smallest number ratio. And those atoms combine to form a compound. Now, how about a molecular formula? It is the actual number of atoms present in a molecule of a compound, the exact number of those atoms. If we say, for example, we had carbon in the empirical formula, how many are they in the molecular formula? Now, this is a stepwise calculation in which an empirical formula leads us to a molecular formula. So I have some 3 examples that I'm going to tackle in this video, and this is one of them. Now, let us read the question together. A compound of carbon, hydrogen, and oxygen, I've written them in simplest way because of space. So a compound of carbon, hydrogen, and oxygen contain 54.55% carbon, 9.09% hydrogen, and the rest oxygen. If its molecular mass is 88, determine its molecular formula. And you're given some molar mass of the compounds. Carbon is 12, hydrogen is 1, and oxygen is 16 grams per mole. That is 1 mole of those particular elements. Now, what I normally advise students is this. First, need to identify the elements that are present in the question. And we are told that a compound contains, let me see, the element, the first one is carbon, the second one is hydrogen, and finally the third one is oxygen. And what are we told? That the percentage by mass of carbon is 54.55%. How about hydrogen? 9.09%. Keep it in mind, we are told that, and the rest is oxygen. Now, at some point in time, these percentages can be given in masses, whereby we are told that the mass of carbon is this, mass of hydrogen is this, mass of oxygen is the other one. Now, in case you're given in terms of percentage, the total percent is 100. Therefore, can I get the percentage of oxygen? Yes, it is very simple. How do I get percentage of oxygen? It will now be 100% minus, when I add this to 54.55% plus 9.09%. Now, when I punch that one in the calculator, I'll get 36.36% of oxygen. Therefore, that will be the mass of oxygen. 36.36% by mass of oxygen. So if I have the percentage of all the elements that I am told or given, how do I get the number of moles of each and every atom? The number of moles is found by percentage or the mass over the molar mass of that particular element. Now, if I have the masses in terms of percentage, the molar mass of carbon, I'm told, is 12. So I divide this one by 12. The molar mass of hydrogen is 1, divided by 1 gram per mole. The molar mass of oxygen is 16.0. So when I divide those things in the calculator, they will give me the number of moles present. And the number of moles that will be present will be equivalent to, in case of carbon, it will be 4.5458 moles. How about hydrogen? It will remain the same, 9.09. And how about oxygen? 2.275. 2.2725, sorry. 25 moles of oxygen. So these are the moles of those particular elements. The next step, we're supposed to divide those number of moles by the simplest value. So between 4.5, 9.0 and 2.2725, which one is the smallest? It is this one. So I divide everything by the smallest value. Divide this one by the smallest value. Divide this one by the smallest value. So when I divide them by the smallest value, I'll get the ratio 2, 4, and 1. This one will be 1, that will be 4, and the other one will be 2. Therefore, the empirical formula will be equivalent to carbon. How many are they? They are 2. Hydrogen are 4, and oxygen is only 1. And there is no need of me writing the 1. I can leave it at that point. Now, next step, we are supposed to write the molecular formula. This is the empirical formula. And empirical formula is gotten from the simplest ratio of the moles of those atoms, of those elements. Now, how do I calculate the molecular formula? This is how. I will now say that C2H4O I multiplied by a constant value n, and the total molar mass should be equivalent to 88. Now, how many atoms of carbon are there? 2. And the molar mass of carbon is 12. So that's why I'll say 12 times 2 plus hydrogen are 4, and the molar mass of hydrogen is 1, plus oxygen is 1, so it will just be 16 times 1. If I multiply by the value n, I should be getting 88. And in such a case, when I sum up all this, the answer will be 44n is equals to 88. And when I divide the value, n will be equivalent to divide by 44, divide by 44. So the answer will be automatically 2. Now, how do I write now the molecular formula? I replace the value of n in this equation. So what will I have? C2H4O but n. So the molecular formula will be equivalent to C4H8O2. So this will be the molecular formula of this compound. Now,